Hello everyone, hope you all are doing good. I am Anjana from LearnoHub, the free learning platform where you can study math, science and SST absolutely free at learnohub.com. In today's class, we are going to discuss ICSE Class 10 Maths Chapter 25 Probability. We will be discussing questions from exercise 25C. We have studied all the concepts in the previous classes. We have solved questions from exercise 25A and 25B. Hope you all have solved the questions on your own. Yes? Let's solve questions from exercise 25C. Here we have the first problem. Question 1 of exercise 25C. A bag contains 3 red balls, 4 blue balls and 1 yellow ball, all the balls being identical in shape and size. If a ball is taken out of the bag without looking into it, find the probability that the ball is first case yellow, second red, third not yellow, fourth neither yellow nor red. Okay, here we have a bag containing 4 blue balls, 3 red balls and 1 yellow ball. What is the total number of balls? Total number of balls is the total number of outcomes. N of S. N of S is equal to 1, 2, 3, 4, 5, 6, 7, 8. There are 8 balls. N of S, total number of outcomes is equal to 8. Now the first case, it should be a yellow ball. I am taking a ball out from this and it should be a yellow ball. How many yellow balls are there? Just one, right? Therefore, for the first case, number of outcomes favorable to the event is equal to 1. There is only one yellow ball. Then, what is the probability of the event? Probability of the event will be equal to number of outcomes favorable to the event divided by total number of outcomes, which is 1 by 8. Okay. Now, the second one, it is a red ball. Here, what is the number of outcomes favorable to the event? The event is the ball being a red ball. How many red balls are there? 1, 2, 3. 3 red balls are there. N of E will be equal to 3. We have N of S is equal to 8. Therefore, probability of the event will be equal to N of E divided by N of S. That is 3 by 8. Next, third one. Not yellow. What does not yellow mean? The ball should not be yellow. If ball is not yellow, it can either be blue or it can be red. Okay. So, except yellow ball, all other balls can be considered. Here, N of E will be equal to, counting 1, 2, 3, 4, 5, 6, 7. That is number of red balls plus number of blue balls. You will be getting 7 balls. Then the probability of the event will be equal to N of E divided by N of S, that is 7 divided by 8. Okay, 7 by 8. Next, fourth one, neither yellow nor red. What does that mean? Neither yellow nor red. It cannot be yellow or red. It can only be blue, which means 1, 2, 3, 4. Okay, so number of outcomes favorable to the event is equal to 4. Probability of the event will be equal to N of E by N of S, that is 4 by 8 equal to 1 by 2. 1 by 2 is your answer. Understood? Second problem, question 5 of exercise 25C. A and B are friends. Ignoring the leap year, find the probability that both the friends will have, first case, different birthdays, second case, same birthdays. Okay. Here, how many days are there in a year? It is mentioned not a leap year. You should ignore the leap year. In leap year, there are only days. When it comes to normal year, it is 365 days. Total number of days in a year is equal to 365. Okay, first case is they are having different birthdays. A person will be having only one day in a year has his birthday, right? Next birthday will be in the next year. So, if A's birthday is on some date, say July 4th, okay, on July 4th, if A is having birthday, different birthdays means The B's birthday can be on any other days except July 4th. Okay. Same birthday means B's birthday will be also on July 4th. Understood? So, different birthdays. Here, only one day should be ignored. Therefore, number of outcomes favorable to the event is equal to, out of this 365 days, one day should be ignored. Okay, one day, if A is having birthday on July 4th, then only that day should be ignored, because on any other days, B can have his birthday. Therefore, 364 days are there. Okay, we have N of E is equal to 364, N of S is equal to 365. Then the probability of the event, probability of having different birthdays will be equal to N of E divided by N of S, which is 364 by 365. We cannot reduce this to a smallest ratio. This is the smallest ratio. Now, the second case. Second case is what? Same birthday. How many days? Just one day, right? Only if that is, taking this example, if A's birthday on July 4th, then B's birthday should also be on July 4th. If A's birthday is on August 4th, then B's birthday should also be on August 4th. Okay, only one day it can be, which means number of outcomes favorable is equal to 1. N of E is equal to 1. N of S is 365. Therefore, probability of the event will be equal to N of E by N of S, which is 1 by 365. Okay, 1 by 365. Clear? Okay, there are more chances for having different birthdays than compared to the same birthday. Only on one day it can happen. Problem 3, question 8 of exercise 25C. All the 3 face cards of spades are removed from a well-shuffled pack of 52 cards. A card is then drawn at random from the remaining pack. Find the probability of getting first a black face card, second a queen, and third a black card. Okay, here we know in a deck there are 52 cards. What is given? All the 3 face cards of spade are removed. How many face cards of spades do we have? Here, this row shows the cards which have the shape spades. Okay, A of spades, spades 2, spades 3, spades 4, spades 5. We have spades jack, spades queen, spades king. The 3 face cards which are removed will be these 3. Okay, these 3 are removed. If these 3 cards are removed, what is the total number of cards? We have 52 cards. Okay, so total number of cards will be equal to total 52 cards. Okay, from this 52 cards, we are removing 3 cards. That is, the face cards of spades are removed. Okay, removing 3 cards. 52 minus 3. What is 52 minus 3? How much do we get? Yes, 49. So, here we have only 49 cards after removing the 3 cards which are spades face cards. Okay. Now, next, we need to find the probability of getting a black face card. How many black face cards do we have? In total, we have 3 black face cards of spades and 3 black face cards of clubs. Okay, here the 3 face cards of spades are removed. Then remaining number of cards which are face cards and of clubs will be taken. It should be black in color. It is given black face card. How many black face card do we have? Here the event is black face cards. Okay, the black face cards are 1, 2, 3. Therefore, number of outcomes favorable to the event. Event is black face card. Okay, number of outcomes favorable to the event will be equal to 1, 2, 3. These 3. 3. Now tell me, what is the probability of the event? Probability of the event is equal to number of outcomes favorable to the event divided by total number of outcomes. Okay, here what is n of s? N of s will be equal to 49. N of s is equal to 49. N of e is 3. 3 by 49. Okay, 3 by 14. This is the required probability. Number of outcomes favorable to the event is equal to 3 and the total number of outcomes is equal to 49. Therefore, 3 by 49. Clear? Next, it is a queen card. How many queen cards do we have? In total, we have 4 queen cards. But a face card which is black in color having a spade is removed. Okay, 3 cards are removed and a queen will also be removed from it. Now, how many face cards do we have which has queen? Queen cards 1, 2, 3. 3 queen cards are there. Yeah, 1, 2, 3. So, total number of cards again here it is equal to 49. N of s is equal to 49. Now, the event is a queen card. So, number of outcomes favorable to the event will be equal to 1, 2, 3. Okay, 3. That is queen of diamond, queen of hearts and queen of clubs. Probability of the event is equal to number of outcomes favorable to the event divided by total number of outcomes. Again, we get 3 by 49. When you get 3 by 49, you cannot reduce it further. Okay, the answer is 3 by 49. Now, the third one. Here the event is getting a black card. A black card. In total, we know how many black cards are there? In a deck of 52 cards, 26 cards, half of 52. 26 cards will be red in color and remaining 26 will be black in color. Now, here what happens? 3 face cards of spades are removed, which means 3 black cards are removed. Now, what is the total number of black cards? A black card. So, n of e will be equal to total number of black cards is 26. Okay. From this 26, how many cards are removed? 3 cards are removed. So, 26 minus 3 which is equal to 23. Or you can just count like this. Number of black cards which has clubs. Here we have 13 cards. Okay. With spades, 3 cards are removed. Then how many cards with spades are remaining? 10 cards. Yes, 13 plus 10 which is again equal to 23. Okay. So, n of e, that is the number of outcomes favorable to the event is equal to 23. Next, total number of outcomes is equal to 49. N of s is equal to 49. Therefore, the probability of the event will be equal to n of e by n of s, that is 23 divided by 49. Even this cannot be reduced. This is your final answer, 23 divided by 49. Clear? Problem number 4, question 18 of exercise 25C. A game consists of spinning an arrow which comes to rest pointing at one of the numbers 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 as shown below. Okay. If the outcomes are equally likely, find the probability that the pointer will point at first 6, second an even number, third a prime number, fourth a number greater than 8, fifth a number less than or equal to 9 and sixth a number between 3 and 11. Now consider this, all of you have seen this, right? Yes. Now when this arrow rotates, it can either be at 1, it can stop at 2, it can be at 3, it can be at 4. There are equal chances. So this is an equally likely outcomes. Okay. Now the first case. What are the total number of outcomes? Here the sample space will include numbers from 1 to 12. All of them have equal chance. 7, 8, 9, 10, 11, 12. Any of this can be the outcome. So, number of outcome, total number of outcome is equal to 12. First case, the event is getting a 6. How many times 6 is appearing? Just once. Okay. So, getting 6 is the first case. N of e will be equal to 1. Only one case. Okay. Therefore, the probability of this event is equal to n of e by n of s, which is 1 divided by 12. Probability of getting 6 is 1 out of 12. Okay. Now the second one. An even number. Select even numbers from this. 2 is an even number. 4 is even. 6 is even. 8, 10 and 12. Okay. Even numbers include 2, 4, 6, 8, 10, 12. So, number of outcomes favorable to the event includes 1, 2, 3, 4, 5, 6. 6. Then the probability of the event will be n of e by n of s, which is 6 by 12. Reducing to smallest, what do we get? 1 by 2. Correct. 1 by 2. Next, the third one. A prime number. Which are the prime numbers here? 2 is a prime number. 3 is a prime number. 5 is prime. 7 is prime. Then 11 is prime. 2, 5, 3, 7, 11. 2, 3, 5, 7, 11. So, number of outcomes favorable is equal to 1, 2, 3, 4, 5. 5. Probability of the event is n of e by n of s, which is equal to 5 by 12. Okay, 5 by 12 is your answer in case of prime numbers. Now, fourth, a number greater than 8. Number greater than 8. Now, tell me, here we have 8. Can we include 8? 8 is not greater, right? So, 9, 10, 11, 12 can be taken. 9, 10, 11, 12. Therefore, number of outcomes favorable to the event is equal to 1, 2, 3, 4. 4 outcomes. Then the probability of the event is n of e by n of s, that is 4 divided by 12. Reducing to smallest ratio, we get 1 by 3. Next, the fifth one. A number less than or equal to 9. It can be 9 or any number less than 9. E includes. We can start from 1. 1 is less than 9. Then 2, 3, 4, 5, 6, 7, 8, 9. Okay. Number of outcomes favorable to the event is equal to 1, 2, 3, 4, 5, 6, 7, 8, 9. Then the probability of the event is equal to n of e by n of s. 9 divided by 12, reducing 3 by 4. We get 3 by 4. Sixth case, a number between 3 and 11. Between 3 and 11 means you cannot include 3 as well as 11. Only values which comes between this can be taken. So, here we have 3, 4 can be taken, 5 can be taken, 6, 7, 8, 9, 10. Up to 10 can be taken, 11 cannot be taken. Okay. Therefore, we have E equal to 4, 5, 6, 7, 8, 9, 10. N of E, number of outcomes favorable to the event. 1, 2, 3, 4, 5, 6, 7. 7. Then the probability of the event will be equal to N of E by N of S, that is 7 by 12. So, we have determined all the required probabilities. Understood? Next, problem number 5. Question 20 of exercise 25C. From a deck of 52 cards, all the face cards are removed and then the remaining cards are shuffled. Now, one card is drawn from the remaining deck. Find the probability that the card drawn is first one a black card, second 8 of red color and third a king of black color. Okay, how many cards are there in total? In a deck we have 52 cards. Now what is happening? We are removing all the face cards. Removing all the face cards. All of these face cards are removed. Okay. Now what is the remaining number of cards? Here the total number of cards is equal to removing 12 cards from 52 cards. 52 minus, here we have 3 cards, 3 face cards with diamond, 3 face cards with hearts, 3 face cards with spades and 3 face cards with clubs. Okay. So total 3 plus 3 plus 3 plus 3 is equal to 12. We are removing 12 cards from 52 cards. We get 40. Therefore, n of s is equal to 40. Total number of outcomes is equal to 40 outcomes. From this 40, the first condition is you should get a black card. Okay. First one, a black card. This is the event. Okay. Number of outcomes favorable to the event is equal to. How many black cards do we have? Total we have 26 black cards. From this 26 black cards, 3 cards with clubs, that is 3 face cards with clubs and 3 face cards with spades are removed. Okay. Then what is the remaining number? 6 cards are removed. 3 plus 3 equal to 6. So here n of e will be equal to 26 minus 6. Or just count these cards. From 8 to 10, how many cards are there? 10 cards. 10 cards with spades and 10 cards with club. 10 plus 10, 20. Okay, 26 minus 6 or 10 plus 10, 20 we get. N of e, that is the number of outcomes favorable to the event here is equal to 20. Okay, now tell me what is the probability of the event? N of e, number of outcomes favorable to the event divided by n of s, total number of outcomes, that is equal to 20 by 40, which is on cancelling we get the smallest ratio is 1 by 2. Clear? Now the second one, we should get 8 of red color. Okay, here we have 8, it should be of red color. Either it should be 8 of diamond or 8 of hearts. How many cards? Just 2 cards. Okay. Therefore, the number of outcomes favorable to the event. Here the event is getting a red 8. N of e is equal to just 2. We have 8 of diamonds and 8 of hearts. Okay. Therefore, the probability of the event is equal to number of outcomes favorable to the event divided by total number of outcomes, which is 2 divided by 40 equal to 1 by 20. 1 by 20 is the smallest ratio. Okay. Next, the third one. A king of black color. King of black color. All the king cards are removed. Okay. King of spades and king of clubs are also removed from this. Yes, if all the face cards are removed, how can I get a king card from this? That too, we need a king of black color. We cannot get king of red color or even king of black color, which means the event here is getting a king of black color. So, number of outcomes favorable to the event. What is the number of outcomes favorable to the event? 0, correct, because we cannot get a card, that is a king of black color. We cannot get. Why? Because these cards are removed. Okay. Therefore, n of e is equal to 0. Then what is the probability? Probability will be equal to n of e by n of s, and that is equal to 0 by 40 equal to 0. Your final answer is 0. Got it? Next, problem 6, question 30 of exercise 25C. Offices in Delhi are open for 5 days in a week, Monday to Friday. 2 employees of an office remain absent for 1 day in the same particular week. Find the probability that they remain absent on first, the same day, second, consecutive day, and third, different days. Okay. Here, 5 days, Monday, Tuesday, Wednesday, Thursday, Friday. These are the 5 days. Okay. So, we have the first person and second person. It can be like Monday. Okay. They can be absent on first person and second person are absent on Mondays. Then, first person is absent on Monday. Second person is absent on Tuesday. First on Monday, second on Wednesday, first on Monday, second on Thursday, first on Monday, and second on Friday. Okay, we are making the possible combinations. Okay, when the first person is absent on Monday, the second person can be absent on Monday, Tuesday, Wednesday, Thursday, or Friday. So we got five outcomes we got. Okay, now when the first person is absent on Tuesday, similarly we will be getting Tuesday, Monday, Tuesday, Wednesday, Tuesday, Thursday, Tuesday, Friday. Next, first person on Wednesday, Wednesday, Monday, Wednesday, Tuesday, Wednesday, 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 Thursday, and Wednesday, Friday. Okay. First person on Thursday, then Thursday, Monday, Thursday, Tuesday, Thursday, Wednesday, Thursday, Thursday, Friday. Okay. First person on Friday, then Friday, Monday, Friday, Tuesday, Friday, Wednesday, Friday, Thursday, and Friday. Okay. Now, what is the total number of outcomes? Total number of outcomes n of s is equal to, here 5 into 5. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25. We have 25 outcomes. N of s is equal to 25. Now the first case. First case is, here the event is the same day. Both of them are absent on the same day. Out of this, which and all we can take? Monday can be taken. Tuesday. Here, this means first person is absent on Monday, second person is also absent on Monday. This first person is absent on Tuesday, second person is also absent on Tuesday. Then Wednesday, Thursday, Friday. So these 5 outcomes can be taken. Okay. So here the outcomes are Monday, Tuesday, Wednesday, Thursday, Friday. Okay. Number of outcomes favorable to the event is equal to, counting 1, 2, 3, 4, 5. 5 outcomes. Therefore, the probability of the event, that is, here the event is both of them being absent on the same day. Probability of the event is equal to n of e divided by n of s, which is 5 by 25. Reducing to the smallest ratio, what do we get? 1 by 5. Yes, 1 by 5 is your answer. Okay. Now the second one. Second, here the event is consecutive days. Consecutive days means the very next day. If one is absent on Monday, second will be absent on Tuesday. Okay. So here, which are the combinations that can be taken? Monday, Tuesday can be taken. Yes. If a person, first person is absent on Monday, then the second person should be absent on Tuesday. Okay. Then, when it comes here, if the first person is absent on Tuesday, then the second person can either be absent on Monday or he can be absent on Wednesday, because both of these are consecutive days. When you consider Tuesday, previous day is Monday and very next day is Wednesday. Okay, so these two can be selected. Next, when it comes to Wednesday and Tuesday is possible, Wednesday and Thursday is possible. Okay, first person being absent on Wednesday, the second person can either be on Tuesday or Thursday. Okay, what about Thursday? Thursday, Wednesday, Thursday, Friday are possible. What about Friday? Friday, Thursday. Friday, Saturday is not there. Therefore, Friday, Thursday can only be selected. So here, the outcomes are Monday, Tuesday, Tuesday, Monday, Tuesday, Wednesday, Wednesday, Tuesday, Wednesday, Thursday, Thursday, Wednesday, Thursday, Friday, Friday, Thursday. Okay. Here remember, Monday, Tuesday and Tuesday, Monday are different. Okay. So, number of outcomes favorable to the event here is equal to 1, 2, 3, 4, 5, 6, 7, 8. 8 outcomes. The probability of the event is equal to n of e divided by n of s, which is 8 divided by total number of outcomes 25, which cannot be reduced to further. So, your answer is 8 by 25. 8 by 25 is the required ratio. Now, the third one, different days. Different days means it should not be the same day. Okay. All other are possible. It can be consecutive days. It may not be consecutive days. Monday, Wednesday, Monday, Thursday, Monday, Friday, everything can be considered. Okay. Let's see here. event is different days. Number of outcomes favorable to the event. You just need to remove this Monday, Tuesday, Wednesday, Thursday, Friday. That is, out of this 25, 5 cases are removed. Okay, same days are removed. Then how much do we have? We'll be having 20. N of E is equal to 20. Just count. 1, 2, 3, 4. From this row you get 4. From this row you will be getting 4. 4 plus 4, 8. Again 4, 12. 12 plus 4, 16. 16 plus 4, 20. Okay, N of E is equal to 20. Then the probability of the event will be equal to number of outcomes favorable to the event divided by total number of outcomes, which is 20 divided by 25. Reducing to smallest ratio, what is the answer? 4 by 5, correct. 4 by 5. Okay, either you can find it like this, or we know that probability of different days, absent on different days, will be equal to 1 minus probability on same days. Okay, right? Probability on same day plus probability on different days will be equal to 1, which means the probability on different days will be 1 minus probability on same days. What is the probability on same days? We have determined, which is 1 by 5. Okay, what is 1 minus 1 by 5? Taking LCM, denominator we get 5. So 5 minus 1, which is 4 by 5. Same answer we are getting. Okay, so probability on different days, being absent on different days, will be equal to 1 minus the probability of being absent on the same day. Clear? Problem number 7, question 31 of exercise 25C. A box contains some black balls and 30 white balls. If the probability of drawing a black ball is 2/5 of a white ball, find the number of black balls in the box. So, a box contains some number of black balls. What does the sum number mean? We don't know how much it is. Let us take this as X. Let number of black balls be X. Okay, there are X number of black balls and 30 white balls. Okay. Then what else is given? If the probability of drawing a black ball, let us write, let probability of drawing a black ball is P of B. Okay, P of B is the probability of drawing a black ball, and that of white ball be P of W. Okay, what is given? It is given 2/5 of white ball, which means P of B is equal to 2 by 5 times P of W. Probability of drawing a black ball is 2/5 the probability of drawing a white ball. Find the number of black balls in the box. We have to find the number of black balls in the box. What is the total number of balls? Total number of balls will be equal to, here we have X black balls and 30 white balls, which means total number of balls will be X plus 30. Okay, that is X plus 30, which means N of S, total number of outcomes, is equal to X plus 30. Okay, first event is drawing a black ball. We don't know the number of black ball, right? We have taken it as X. So, probability of drawing a black ball will be equal to number of black balls, number of outcomes favorable to the event, that is drawing a black ball, which is X divided by total number of outcomes, total number of balls. Here the total number of balls is X plus 30. What about P of W? Probability of drawing a white balls, number of outcomes favorable to the event. Here the event is drawing a white ball. Given number of white balls is 30, 30 by X plus 30. Okay. Now, Consider this. P of B is equal to 2 by 5 times P of W. P of B is x divided by x plus 30 is equal to 2 by 5 times 30 divided by x plus 30, where 30 by x plus 30 is the P of W, probability of drawing a whiteboard. Now this x plus 30 can be cancelled from the left side and right side. Okay. Taking this 5 to the opposite side, we get 5x. 5x is equal to 2 into 30. 2 into 30 is 60. Then what is x? X will be 60 divided by 5. What is 60 by 5? 12. Correct. 12 is your answer. Number of black balls is equal to 12. Number of black balls is equal to 12. Okay. Problem number 8. Question 35 of exercise 25C. A game of numbers has cards marked with 11, 12, 13, etc. up to 40. A card is drawn at random. Find the probability that the number on the card drawn is, first one, a perfect square, second, divisible by 7. Okay. Here the sample space includes cards with number 11, 12, 13, 14, etc. up to 40. What is the total number of outcomes? Starting from 11, counting up to 40. How many numbers are there? There are 30 numbers. Okay. 30 cards are there. 30 you got. N of S is equal to 30. Now come to the first one. A perfect square number. Tell me, what are the perfect square numbers? We have 1 is a perfect square number. Then 4, 2 square 4, 3 square 9, 4 square 16, 5 square 25, 6 square 36, 7 square 49. Now check the cards. Here the cards include from 11 to 40, which means you don't need this 1, 4 and 9. 16, card 16 is there, card 25 is there, card 36 is there. Card 49 will not be there, it is greater than 40. So only up to 40 we have. So you cannot include this also. 1, 2, 3. So here E is equal to 16, 25, 36. Number of outcomes favorable to the event is equal to 1, 2, 3. 3 even. Okay. Now here we have N of S is equal to 30. What is the probability of the event? P of E is equal to N of E divided by N of S. That is 3 divided by 30 equal to 1 divided by 10. Okay. 1 by 10. Next, second. Divisible by 7. Tell me the multiples of 7. 7 ones are 7. 7 twos are 14. 7 threes are 21. 7 fours are 28. 7 fives are 35. 7 6 are 42. Now check the cards. Here do we need 7? 7 is not included in the card. Then 14 is there. 21 is there. 28 is there. 35 is there. 42 is also not included. Okay. So how many values? 1, 2, 3, 4 values. Here E is equal to 14, 21, 28, 35. N of E is equal to 1, 2, 3, 4. N of S is 30. Then what is the probability of the event? N of E divided by N of S. N of E by N of S. Number of outcomes favorable to the event divided by total number of outcomes will be equal to 4 by 30. Reducing to the smallest ratio, we get 2 by 50. 2 by 50. Okay. Problem 9, question 38 of exercise 25C. A box contains a certain number of balls. Some of these balls are marked A, some are marked B, and the remaining are marked C. When a ball is drawn at random from the box, probability of getting A is equal to 1 by 3, probability of getting B is equal to 1 by 4. If there are 40 balls in the box which are marked C, find the number of balls in the box. Okay. Here, what is given? The probability of A is given 1 by 3. Probability of B is given 1 by 4. Okay. Then we don't know what the probability of C is. We know that the probability, total probability will be equal to 1. Why? Because if you are drawing a ball, either it should be marked as A, or it should be marked with B, or it should be marked with C. Which means the probability of getting A plus the probability of getting B plus probability of getting C should be equal to 1. Now put the values. P of A is 1 by 3, P of B is 1 by 4, P of C we don't know, probability of getting C we don't know, and that is equal to 1. Now find P of C. Here taking LCM, 1 by 3 plus 1 by 4, the LCM will be 12, denominator will be 12. 3 into 4 is 12, 4 into 1, 4, plus 4 into 3 is 12, 3 into 1, 3, plus P of C is equal to 1, 4 plus 3, 7 by 12 plus P of C is equal to 1. Then what is P of C? Probability of getting a ball which is marked with C will be equal to 1 minus 7 divided by 12. How much do we get? Denominator 12, numerator 12 minus 7. That is 5 by 12. So probability of getting a ball marked with C is equal to 5 by 12. Okay, we got the probability. What is the total number of balls that are marked C? Number of balls marked C is your event. Okay, N of E will be equal to 40. The number of balls which are marked C is equal to 40. What is the probability then? Here the event is getting a ball which is marked C. N of C is equal to 40. Probability of getting a ball marked with C is equal to number of outcomes that is favorable. In this case, getting a C, number of balls marked C is equal to 40 divided by total number of balls. This is what we have to determine. Let us take the total number of balls. Here it is just given certain number of balls. Let the number of balls be taken as X. Okay. Total number of balls. X is total number of balls. We are taking as X just because to make the calculation easier. Now find the value of X. We have P of C. P of C is 5 by 12. 5 by 12 is equal to 40 divided by X, which means cross multiplying X is equal to 40 into 12 divided by 5. 5 into 8 is 40. 8 into 12. 8 into 12, 96. Therefore, we'll be having total number of balls. The number of balls is 96 balls. Okay, there are 96 balls. Clear? That's all for today. In today's class, we have discussed problems from exercise 25C. There are a few more problems which are left which you can solve on your own. I'll be back in the next session. Until then, stay tuned to LearnoHub. LearnoHub free hai par best hai. Thank you.